This is Mr. Anderson for Kellogg Community College taking a look at Chapter 7, Section 4, Dividing Rational Expressions for Intermediate Algebra Math 121. This is the first part of two videos where we're going to be looking at just simplifying things using dividing. And I should say this disclaimer, we will assume that all variables represent positive numbers because we are not going to look at positive and negative versions of each square root, fourth root, sixth root, or if the index is even. Now, the quotient rule for radicals is pretty straightforward. If you have the nth root of a divided by b, you can break that into the nth root of a divided by the nth root of b, which will allow you to simplify and simplify each of these separately. Also, you'll probably notice that about halfway through this worksheet, they're going to start out with these separate. You can also reintegrate that back into a combined form to do some simplification that way. So starting out with problem 1, we can split this into the square root of 81 divided by the square root of 25, because 81 divided by 25 isn't going to be a whole number. But if I take the square root of 81, which will be 9, and the square root of 25, which is 5, then that gives me a nice solid answer. Same thing for problem 2. Square root of 144 divided by the square root of x squared. The square root of 144 is 12. And the square root of x squared, 2 goes into 2 once, so that leaves me with just x. You'll also notice that every single answer that we'll get here will have this denominator being non-radical. In the case that we do have some problems that have a radical in the denominator, we're going to cover that in the second video, which is going to be about rationalizing denominators. Okay, take a look at problem number 3 here. This gives us a, oops, got to move my keyboard here. That keyboard was in the way. Alright, so in problem number 3 here, we're going to take a look at this separately. We're going to take a look at the cubic root of 64 x to the 7th divided by the cubic root of 216 y to the 6th. If we look up the cubic root, and we'll notice that the cubic root of 64 is just 4, and that's kind of nice because we can break this using our properties from yesterday into the cubic root of 64 times the cubic root of x to the 6th times the cubic root of x to the first power. Now, you can see that I'm taking the slow way again, and I'll speed up when we get to problem 4 here, but you can see that I have 6 and 1 that makes 7. And I'm looking for multiples of 3 here, so I have even radicals. Now down here, this is the cubic root of 216 multiplied by the cubic root of y to the 6th, which is a perfect divisor into 3. So what this is going to leave me is with the cubic root of 64, which is going to be let's see, the cubic root of 64 is going to be 4. And x to the 6th divided by 3, or x to the 6 thirds, gives me with 2. And this cubic root of x is still trapped inside there, nothing to do there. 216 is, the cubic root of 216 is going to be 6. And this cubic root of y to the 6th is y to the 6 over 3. So this is y squared. And this is going to leave me my answer here. So again, you can see that I kind of broke things down a little slower up here. I can take a faster approach, and from working with yesterday's video, you can say to yourself, okay, so if I'm looking at just the numerator, which is going to be the fourth root of x to the 9th, y to the 12th, 9 doesn't go into 4 evenly, but or 4 doesn't go into 9 evenly, but 4 goes into 8 evenly, so that would leave me with x squared with one of my x's left over. And 4 does go into 12 evenly 3 times, so this is y cubed, and with no y's left under the radical of 4. Now in my denominator, 4 does not go into 15 evenly, but 4 goes into 12 evenly 3 times. So this is going to be z to the third power, which leaves me with, in my denominator here, the fourth root of how many z's were left over from 12, which is going to be 3 of them. Now my final answer is going to have x squared y cubed divided by z cubed times the quantity of the fourth root of x over z cubed. Now, this answer has a square root in the denominator, well, or fourth root in the denominator. So what we're going to learn in the next section is how to get rid of that. So stay tuned for the next video on how to get rid of a radical in the denominator. Alright, let's look at problems 5, 6, 7, 8, 9, and 10 to finish up this video. Okay, now, just as we broke apart the radicals, these problems are meant to be put back together. So I can bring this in under one radical, 700x divided by 7x, which makes the square root, 700 divided by 7 is 100, and x divided by x is 1. So this leaves me with the square root of 100, and since we're not dealing with any negative possibilities, we're just going to have the answer of 10, whereas this would be either plus or minus 10, or the absolute value of 10 if I didn't have that exclusion from the beginning of the worksheet. Now this here is the cubic root of 35 divided by 5, which I can do in my head is 7. Well, nothing to do there. Now here I'm going to put these together and divide the two of them. So this is going to be 189 divided by 7. Doing a little calculator work here, that's going to be 27. And remembering my rules of exponential simplification, x to the 5th divided by x squared is x cubed. And y to the 7th divided by y squared is y to the 5th. Now let's go and simplify this. The cubic root of 27 is going to be 3. The cubic root of x cubed, 3 goes into 3 once, so that leaves me with an x. And 5 does not divide 3 evenly, but 3 divided by 3 very evenly, leaving me with 2 y's left over in my cubic root. And there's my answer there. Alright, things are getting a little trickier since we have negative exponents, but let's put this all under the same fifth root here. 64 divided by 2 is 32. 11 x to the 11th over x squared is x to the 9th. And this negative 2 moves to the upstairs, so that becomes y to the 30th. Alright, now let's go break these apart piece by piece. The fifth root of 32 is 2, because 2 times 2 times 2 times 2 times 2 is 32. 2, 4, 8, 16, 32. Now, 9 does not divide 5 evenly, but 5 goes into 5 evenly once, leaving me with 4 left over. So this answer is going to have x to the 4th, at least an x to the 4th to in it left over from that. Now 5 goes into 30 evenly 6 times, so this is y to the 6th power. And that's your answer for number 8. Problem number 9. Let's see what luck brings us here. 192 divided by 3, that's going to give us, let's see here, 64. Alright, so far so good. X to the 9th divided by x to the 4th is going to be x to the 5th power. And then y to the 17th, y to the 21st. Oh no, this is going to have us denominator heavy, y to the 4th in the denominator. So I'm going to, now that I've combined and made this easier, I'm going to split this back up again into two pieces. 64x to the 5th in the numerator, and in the denominator, the square root of y to the 4th. The square root of 64 is going to be 8. And the square root of x to the 5th, now since the index here is 2, 2 does not go into 5 evenly, but 2 will go into 4 evenly, leaving me with x squared. 4 divided by 2 is 2. And this leaves me with 1 square root of x left in the numerator. In the denominator, 2 does go into 4 evenly pretty nicely, so 4 divided by 2 is 2. So y squared is our answer there. Okay, problem number 10. We're going to check mark the 4 here. Let's do some simplification and see what we can do here. Unfortunately, we're going to have a denominator because the 16 is, well, there's no whole number in the numerator to simplify with that. But here we have x to the 12th over x squared, so that's going to be x to the 10th. And this is going to be y to the negative 14th over y squared. The negative 14 moves downstairs. This is y to the 16th in the denominator. So that means I got to break this back apart again. So I'm going to have x to the 10th in the numerator in the 4th root, and in the denominator the 4th root of 16 y to the 16. Now that denominator is going to clean up pretty nicely, so let's work on the numerator first. 4 does not go into 10 evenly, or I should say 10 does, so 4 does not go into 10 evenly, but 4 goes into 8 evenly. 8 divided by 4 is 2, and that leaves me with the 4th root of x squared. because 8 and 2 make 10. So there's where I got my 8, and there's where I have my 2. All over the 4th root of 16, which is 2, and y to the 16th, and you take the 4th root of that. This leaves me with y to the 4th power, because 16 divided by 4 is 4. All right, well, stay tuned to the next video to see how we rationalize denominators in this section.